In this video, we're going to look at a couple different rational functions and their graphs. So we're going to start with this one. A few things that we have already learned about are how to simplify rational expressions. And so we've talked about how we could simplify the x minus 2 over x minus 2. A factor divided by itself would equal 1, so those would cancel out. Another thing we've talked about with rational functions is that you cannot divide by 0. Dividing by 0 is undefined. And so looking at our equation here, let's consider what values of x will make the denominator equal 0. And so for this x, if this x were a positive 2, then 2 minus 2 is 0, and then if you multiplied 0 by anything, you would get 0 for the whole denominator. So this is one of the values of x that makes the denominator equal 0. The other value would be a negative 3. If this x were negative 3, then the entire denominator would end up equaling 0. So let's take a look at the graph of this rational function. All right, so we are looking at the graph now of this rational function. So I've already got it typed into the Desmos website. And we were just discussing how the values of x that make the denominator equal 0 are positive 2 and negative 3. So let's see how those show up on the graph. So first, on the graph, take a look at where the vertical asymptote is. And that's here at negative 3. So that's coming from this factor in the denominator, right? If this x value here were negative 3, then our entire function would be undefined because we would be dividing by 0. But what about the factor that canceled out? So when x is 2, our function is also undefined. But over here on the graph, it's not like there's an asymptote here at positive 2. So let's see what's going on. So if I click on this graph at 2, notice it says that it's undefined. When x is 2, the y value is undefined. And the way that that point shows up on the graph is it's an open circle. It's not filled in. This is what is called a hole in the graph. And so a hole occurs when you have a factor that cancels out in a rational function. So the factor in the denominator, the x plus 3, the factor that did not cancel out, that creates a vertical asymptote on the graph at negative 3. But the factor in the denominator that did cancel out, the x minus 2, that creates a hole in the graph, and in this case it would be when x is positive 2. So from the graph, we just saw that there is a hole at x equals positive 2, and there is a vertical asymptote at x equals negative 3. So the hole was created by the factor that canceled out. The factor in the denominator that did not cancel out created the vertical asymptote. So together, holes and vertical asymptotes are referred to as domain restrictions. Domain, remember, means all the x values in a function. So domain restrictions, it's the values of x that make the denominator equal 0. That would make the function undefined. And so for this equation, we actually have two domain restrictions, positive 2 and negative 3. One of them is the hole, and one of them is the vertical asymptote. And so we could rewrite this rational function that we started with our domain restrictions written next to it. So in this function, x can equal any number at all, except for positive 2 and negative 3. If you plugged in a positive 2 for all of these x's, you would end up with a 0 in the denominator, and so that would be undefined. Same thing with a negative 3. If you plugged in a negative 3 for all the x's, you would end up with a 0 in the denominator, and so it is also undefined. The difference between these is that one of them is the hole in the graph from the factor that canceled out, and the other one is the vertical asymptote. So we're going to look at another equation now, another rational function, and it looks like this. And we'll look at the graph of it in a moment. But let's first think about what values of x make the denominator equal 0, or what are our domain restrictions. And so in the denominator, if this x were a positive 5, then we would have a 0 in the denominator. And if this x were a negative 1. So our domain restrictions for this equation are positive 5 and negative 1. These are the only two values of x that this function cannot equal. So which one is the whole and which one is the vertical asymptote? So notice that the x plus 1's could cancel out. And so this -1, that is going to be where the whole is in the graph. So there's going to be an open point. So it's going to be like this at that point, an open circle. And then the +5, the factor that did not cancel out in the denominator, this is where there is going to be a vertical asymptote. So we're going to take a look at the graph and see if this really is true. And notice before we look at the graph, notice this does have a negative in front of the fraction. So be thinking about how that's going to change the graph. So before I display this graph, we just said that there would be a whole at -1 and a vertical asymptote at +5. So let's see if we're right. So the vertical asymptote should be easy to spot, and yes, it is here at +5, so we were right about that. And then we said that the whole in the graph would be at -1. So if I go to an x value of -1 and click on our graph, that point is undefined, and it is displayed as an open circle. It is a hole in the graph. The last thing we're going to look at in this video is what if you wanted to graph this function by hand. So what I've got here, I've already drawn in an x and a y axis, and I've drawn in the vertical asymptote at +5. If we wanted to graph this by hand, we know that the x value of the whole would be at -1. But where would its y value be? Like, would the whole be somewhere down here? Would it be up here? If so, how far up? So we're going to look at how to find the y coordinate of the whole in the graph. So this equation, it did simplify if we canceled out the x plus 1's. And so the simplified form of that equation would look like this. So y equals -1 over x minus 5. So if we want to figure out where the y coordinate of the whole is, we know that the x coordinate of the whole is at -1. So in this equation, I'm going to plug in a -1 for x. So this would be -1 over, and then -1 minus 5. This will get us the y coordinate of the whole in the graph. So in the denominator, -1 minus 5 is -6. So now we've got -1 over -6. Or this could also be written as -1 over -6. You could write the negative with the numerator. A negative divided by a negative is positive. So 1/6. So when the x value is -1, the y value is 1/6. So the whole in the graph is at this location, -1, +1/6. And so on the graph, that would be up just a little bit from the -1. So I'm going to draw that open circle there, and that is the hole in the graph. And then I could draw in the rest of the graph. Because this is negative, I know that my two sections of the graph are going to be up here and down here. And so the graph is going to look something like, it's not going to go through the hole. So I'm going to start just on one side of it and go up towards the vertical asymptote. And then on the other side of the hole, it's going down towards the x-axis. And then this section of the graph down here is just like a reflection of this part, but without a hole in it. So like this. So this is how you would find the y coordinate of the hole in the graph.